All right, starting off lesson 4.3b, right triangle trigonometry. Okay, there's a lot of properties you have to memorize here. These are known as your identities. All right, we have reciprocal identities, quotient identities, Pythagorean identities. Okay, so here we have sine of theta. Then we have its reciprocal identity, okay, which is just 1 over cosecant theta. All right, and the same applies going the other way around. Then we have cosine theta, it's equal to 1 over secant theta. Tangent theta is 1 over cotangent theta. And the reverse as well for the other trig functions. And then you have the quotient identities. Tangent is equal to sine over cosine. Cotangent is just the opposite. It's equal to cosine over sine. Then you have the Pythagorean identities. Sine squared plus cosine squared. Now they both have to be squared. That's why it's called Pythagorean. All right, and that's equal to 1. Then we have tangent and secant. All right, 1 plus tangent equals secant squared theta. And then 1 plus cotangent squared equals cosecant squared theta. All right, so this is the only one where the trig functions are grouped together. And for the other two, you're adding 1 to either the tangent or the cotangent. All right, so let's see how it works out when applying these properties. So use the trig identity to transform the left side of the equation into the right side. Okay, so we're not doing anything to the right side of the equation here. I'm just focusing on the left side, and I'm manipulating it using my trig identities. All right, so I have cosine theta times secant theta equals 1. Well, I have cosine theta, and I know secant theta is equivalent to 1 over cosine theta. All right, that's just based off of the reciprocal identity. I'm just giving a reason here. All right, I just used my reciprocal identity. All right, if you could read that. All right, so the cosines cancel out then, and that's equal to 1. So check. We've achieved our goal. The right side is now the same as the left side, okay? So never do anything to the right side. Don't move anything over to the other side. Just simplify one of the expressions on one of the sides of the equation and make it look like the other side. All right, for part B, first thing I'm going to do here is distribute. You typically start off with the more complicated looking expression. All right, and I'm going to have 1 minus sine of theta here, plus sine of theta, and then minus sine squared theta. All right, and that's equal to, these cancel out, 1 minus sine squared theta. Alrighty, and what can I do next? Okay, if you just look at this piece here, all right, I could apply the Pythagorean identity. Now when you look at the Pythagorean identity in its plain form, that involves sine squared and cosine squared, oops, you have this. Okay, now it may be a little confusing in the beginning, but if we manipulate this Pythagorean identity, I end up with this. All right, now this has nothing to do with the problem right now. This is just messing with the Pythagorean identity. Okay, so now I have something that I could work with. So here I have this sine squared here. Somehow I need to change this so it includes cosine squared theta. Well, messing around with the Pythagorean identity, I'm able to come up with an alternate form of the Pythagorean identity, and sine squared theta is equal to 1 minus cosine squared theta. So I take this and I substitute it in for 1 minus, or not 1 minus sine squared theta, just the sine squared theta. So I end up with 1, which is this piece here, minus this piece, which is now being replaced by this. So that's minus 1 minus cosine squared theta. Now, if I left it as is right now, that would be a serious mistake because you have to put this quantity in parentheses. All right, so then I distribute, and I end up with 1 minus 1 plus cosine squared theta. The ones cancel out, and I get cosine squared theta. Check. All right. That's all you're doing is getting the more complicated side to look like the other side, the simpler side. All right, for part C, notice that we have squares here again, and we're going to possibly use the Pythagorean identities here, typically when you're using a square. All right, so I'm going to use the Pythagorean identity again. And notice that I have, sorry, writing is terrible here. All right, notice that I have only a sine squared on the right side. So somehow I have to get rid of this cosine squared. So using the Pythagorean identity, okay, I'm going to isolate the cosine squared this time. All right, can manipulate it in different ways to serve you. All right. All right, so now I can replace the cosine squared theta with 1 minus sine squared theta, okay? So all this just had to do with the Pythagorean identity. Now I'm going back to the actual problem. I started with sine squared theta, and now I'm replacing cosine with 1, let's use blue, 1 minus sine squared theta. And it's minus here, so don't forget to put parentheses. Or I'm going to have to distribute the negative now. I get sine squared theta minus 1 plus sine squared theta. All right, notice that I have like terms here, so it's just as if sine squared theta was replaced with an x. I have x plus x is 2x. Sine squared theta plus sine squared theta is 2 sine squared theta. And then I have minus 1. All right, so I obtained the right side. Check. My objective is complete. All right, so let's go on to part D. All right, so these problems may be a little confusing at the start, but the more familiar you get with the identities, the easier it will be able to see what you should do, what the next steps are. All right, so I have to simplify this craziness to become that. All right, so how am I going to do that? Well, let's see. I have the quotient identities I could use. I could replace tangent beta with sine beta over cosine beta, and the cotangent with cosine beta over sine beta, and that's all over sine beta over cosine beta. Okay, and I'm going to multiply the top and the bottom by cosine beta. All right, and I distribute, and I get sine beta. So it looks pretty crazy in the beginning, but watch what's going to happen. All right, and as you work with these problems, you'll begin to notice what's going to happen. And you'll be able to apply the properties in such a way that they'll work for you. Okay. Actually, let me take this away real quick, just so this makes more sense. Just doing everything step by step. All right, then I have cosine squared beta over sine squared beta. Okay, so simplifying that, these cancel out here, so I'm left with 1. And then I have, oh, I shouldn't have written square there, darn it. No square. Okay, now it's going to be a square. So we have cosine squared beta over sine squared beta. And from that, I could rewrite that using the quotient identity as 1 plus cotangent beta squared. And applying the Pythagorean identity to this, that's equal to cosecant squared beta. All right, so check. My goal was achieved. All right, so this looks pretty crazy here, but like I said before, the more familiar you get with the properties, the better you'll be able to see how it's going to help you lead you to the right direction. All right, on to the next example. Okay, you're going to use your TI calculator now, and hit the mode button and make sure your calculator is in degree mode for doing these problems, since we're working with degrees. All right, and for the first problems A and B, just plug it in your calculator and round your decimal, all right, to the nearest 3 decimal places. All right, and you'll get this for the first. All right, and you'll get approximately, all right, 0.435 for the first. And for cotangent, you don't have cotangent on your calculator, so what do? We'll use the reciprocal property. You can rewrite it as tangent of 66.5 degrees. Plug that in your calculator, and that's approximately equal to 0.435. Approximately. All right, and for part C, here we have DMS form, degrees, minutes, seconds form. So let's convert this into a decimal first. I take the 50, I divide it by 60, and I get 0.83. Then I take 12, I divide by 3,600, and that's equal to 0.003. Okay, so then I combine those together and I get cosine of 4.833. Okay, and plugging that in the calculator, that's approximately equal to 0.996. All right, that's all there is to it. Just using your calculator for these. Going on to the next example. Find the values of theta in degrees and radians without the aid of a calculator. Okay, so this is square root of 3 over 1. I'm going to construct a triangle now. I don't know what theta is. All right, this is opposite over adjacent. So opposite is square root of 3, adjacent's 1. All right, now looking at these side lengths, you should realize that there's a relationship here. All right, if I multiply this leg by square root of 3, I end up with the other leg. That's the property of a 30, 60, 90 triangle. So this is my short leg, so across from it should be the 30-degree angle, and that means the other one is 60 degrees. All right, so my theta then is 60 degrees, or as radians, it would be 60 times, what's your converting fraction for radians? It's going to be pi over 180, all right, because pi radians is equal to 180 degrees. All right, so the degrees is gone here. 60 goes into 61, so 60 goes into 183 times. So I get pi over 3. Goes into 184 times. So that's pi over 4. All right, pi over 4 radians. Done with that. Okay, in this problem we're working with a 60, 90, 30 triangle. Okay, 30, 60, 90. And across from the 30-degree angle is the short leg. All right, now we always go by the short leg when figuring out the other lengths of the triangle. So what do you do to the short leg to get to the hypotenuse? I multiply it by 2. So 2 times the short leg is equal to the hypotenuse. All right, cool. Now I can solve for x. X is equal to 9. Got that. All right, now what do you do to the short leg to get the long leg? Well, I multiply the short leg by square root of 3, and that gives me the long leg. So y is equal to 9 square root of 3. All right, so you're essentially just going backwards in this problem to obtain the short leg, and then from there you get the long leg. That's all there is to it. If you have any questions, please make sure to ask. Begin the assignment at the bottom of the webpage.